Hello, welcome to the section Types of Data from the chapter Basic Ideas. By the end of this section, you will be able to understand the structure of a typical data set. You will distinguish between qualitative and quantitative variables, distinguish between ordinal and nominal variables, and distinguish between discrete and continuous variables. Let's start with a definition. If you remember from our investigative process of statistics, we first pose a question and then we collect information in an attempt to answer that question. That information collected will be called data set. Let's take this table as an example of a data set. If you notice, information is collected on individuals. In this data set, we have a total of 5 students from which we collected information. We have different characteristics about the individuals for which we collected information. We have major, exam score, and grade. Those will be called the variables. And the different values for those variables are going to be called the data. So for the major variable, we have psychology, business, communication, and I cannot see the last one because it's blocked. For the exam score, our data values or our data set are 92, 75, 82, 72, and 85. And for the variable grade, our data is A, B, and C. Or A, B, B, C, B, sorry. Okay, let's practice looking at the data set and collecting some information. Take a look at this table and answer the following questions. Feel free to stop the video here if you want to practice doing it on your own. The questions are: how many individuals are there? What are the variables? And what are the data for individual number 3? Okay, how many individuals are there? We have a total of 6 individuals. What are our variables? Their political affiliation, their age, and whether they voted or not in the last election. What is the data set, or what are the data for individual number 3? Democrat, 21, and no. That's the data for number 3, or for individual number 3. I know this was a short example, but that's it. Data, variables, data set are just a definition. Let's go over the different types of variables. First, we have 2 types of variables: qualitative and quantitative. Qualitative variables are categorical variables. They classified individuals into categories. And quantitative variables are numerical and tell us how much or how many of something there is. Let's try to start identifying which one would be qualitative and which one will be quantitative. Let's practice. If you want to, feel free to stop the video here and try to classify the following: a person's age, a person's place of birth, the mileage in miles per gallon of a car, and the color of a car. A person's age will be quantitative because we use a number to represent the person's age. Would be 1 year old, could be 14, could be 71 years old, etc. A person's place of birth will be qualitative. It's not numerical. For example, somebody was born in London, Paris, or Tokyo. The mileage of a car will be quantitative because we're talking about how many miles a car can go on a gallon of gasoline. We use numbers to represent the mileage of a car. And the color of a car will be qualitative because it's not numerical, we don't use numbers. The color of a car could be blue, red, yellow, etc. Okay, now that we classified or separated our qualitative and quantitative variables, we're going to talk about particular quantitative variables and particular qualitative variables. Okay, we separate variables into qualitative and quantitative. And then qualitative variables could be classified as ordinal or nominal. Quantitative variables could be classified as continuous or discrete. For distinguishing between ordinal and nominal qualitative variables, ordinal variables are qualitative variables whose categories have a natural ordering, and nominal variables are the qualitative variables which do not have natural ordering. For example, again, let's try and practice distinguishing between ordinal or nominal. Feel free to pause the video and then attempt to answer them on your own. The state of residence of a person, the gender of a person, the letter grade in a statistics class, whether it's A, B, C, D, or F, and the size of soft drink ordered as a fast food restaurant, small, medium, and large. Again, feel free to pause the video. The state of residence does not have a natural ordering, so it will be classified as nominal. Same thing with gender, the gender of a person. It doesn't have a natural ordering, it would be nominal. Now, for the letter grade, yes, we normally arrange them from high to low, A, B, C, D. So this one would be considered ordinal. And the size of soft drink, yes, it's also ordinal because we usually arrange it from least to greatest. That's the difference. That's what we mean by natural ordering. Like in your mind, you normally start in a particular pattern, whether it's by size, by altitude, by, I don't know, by whatever you decide to classify it, order it. Okay, now out of our quantitative variables, we can classify them as discrete or continuous. Discrete variables are quantitative variables whose possible values can be listed. The list may be infinite, but they can be listed. Continuous variables are quantitative variables that can take on any value in some interval. The possible values of a continuous variable are not restricted to a list. If you want to have like a shortcut or like a cheat trick on how to remember this, think of discrete variables can only be whole numbers, and continuous variables are since they can be any value in some interval, it could have a decimal point, 1.2, 1.3, 1.25, and it will be hard to list continuous variables. Imagine 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.6, and so on, or 1.65, 1.66, 1.67. It will be really hard. Discrete variables are just whole numbers. Let's try to classify quantitative variables and distinguish them between discrete or continuous. The age of a person at his or her last birthday, the height of a person, the number of siblings a person has, and the distance a person commutes to work. Feel free to pause the video. The age of a person would be discrete because we can only be 0 years old, 1 year old, 2 years old, 3 years old, and so on. You don't go around saying 1.5 unless you're like on the early stages of life when there's a baby. We do say in the months or days, but as you grow older, you don't say 1.5, like 20.5, 20.75 years old. What about the height of a person? It's also continuous. You don't jump from 5 feet to 6 feet tall. It could be any number in between 5 feet and 6 feet. The number of siblings a person has, that one would be discrete. The possible values are none, 1 sibling, 2 siblings, 3 siblings, and so on. We don't have half siblings. I'm talking about the amount or quantity of a person, not in the sense of the half brother, half sister. Now, the distance a person commutes to work, this one will also again be continuous. It's not restricted to a list, and you can travel 1.2, 1.5, or 12.3, 13.3 miles to work. Now, I'm going to introduce another definition when, when it comes to quantitative variables, ratio, and interval levels of measurement. A variable has a ratio level of measurement if 0 represents the absence of the quantity and ratios are meaningful. And a variable has the interval level of measurement if 0 does not represent the absence of the quantity and ratios are not meaningful. Differences are meaningful, however. For example, if we're talking about the number of siblings you have, going back to our possible definitions, it's a ratio level of measurement if 0 represents the absence of a quantity, and it's an interval level of measurement if 0 does not represent the absence. The number of siblings you have, does 0 represent absence of siblings, like no siblings? Yes. So that one would be a ratio one. The outdoor temperature in Celsius. When it's 0 Celsius outside, does that mean that there's no temperature? No. Then this one will be an interval. An interval. Level of measurement. I'm sorry. This one should be pink. The year of your birth in relation with your birth. Let's suppose you were born on the year 2003. That would be 0 considered in your. Sorry, that would be considered 0 in your age. You were not here, so that one will be considered interval. Because although you were not here, does not mean the absence of time. It's the beginning of your time, but not the beginning of time. I hope that's clear. And the sale price of a car. If it's $0, if it costs $0, does that mean the absence of a cost? Yes, that means it will be free. Again, this one's a little bit tricky. I hope you don't have issues with this one. But whenever 0 represents the absence of a quantity, that's ratio level of measurement. Whenever 0 does not represent the absence, that will be interval level of measurement.